Hello and welcome. Today we're going to have a short tutorial on OpenOffice Base, the relational database product included with OpenOffice, a free download office software offered by Oracle, which is a little outdated but still very useful. OpenOffice Base is the only easily acquired free RDBMS that's out there. Oracle and SQL Server are also available, but they take they're higher learning curve. So if you want to start with a simple system, this is a great opportunity. OpenOffice Base is part of a larger suite with a spreadsheet and a word processor and a drawing program and even a very useful equations mapping program. You may have seen my previous tutorial, What is a Database? I'll add a card so you can watch it now if you haven't. You should watch that first. A database is a collection of tables or spreadsheets, if you want to call them that, or flat files, or collection of different rectangular data, two-dimensional square tables with columns and rows like you see in any spreadsheet. But a database knits together the spreadsheets in using relationships, using shared common attributes that the different tables have with each other. Relational databases allow you to store enormous amounts of data efficiently and query it precisely. It allows you to store different types of data, different types of tables, and you can query the different tables and get different kinds of data out of the database and shape it as you need. I'm a little abstract, but you'll see soon what I mean. So before you start, go to Oracle or Apache and download OpenOffice. It's free. It may require registration. I don't think it did. It's very small. You will also have to run Base. You'll need to download and install the Java Development Kit from Oracle or Java, same company. JDK is not the same as Java. You already have Java probably on your machine. Base will not run without the runtime environment included in the Java Development Kit. And of course all of this is for Windows. I don't know about Mac. But OpenOffice is a useful program, more useful than Google Sheets and other Google apps because it does have a relational database and Google Apps does not. And after you've downloaded and installed OpenOffice, you have a welcome screen. The welcome screen allows you to open any of the features from the first page. We'll select database, and this is the opening dialog for the database. We want to select create a new database. We don't have any existing databases yet, so you create new database. It also queries whether you want to register the database. That is extremely useful for later on when you make real databases because so much work goes into them that you need to store them away from your client. You need to store them on a network or on the cloud so that they can be recovered. Registration helps that process, but we're not going to do that for this elementary exercise. And There was, of course, the option open the database for editing, which we will do also. Select that option. So once we select we want a new database, this is the landing page from which we will create tables and run queries. Right now we're just going to create tables. Oftentimes other people will want you to load tables that already exist. That's a perfectly great way of doing it. But I want people to see precisely how tables are created, and also want very simple tables so that it isn't too confusing. So select the tables option on the left-hand pane, and then under tasks you create table in design view. Design view gives you the ability to see behind the scenes how the table is constructed. This is design view. Now picture this. Now when you start a spreadsheet, you create the column name by typing it in the first row. Can't do that with relational databases. They're more complex. You have a separate form where you enter the column names for each table. This is the form. So the column names will be filled in one after another in these lines. So rows in this table will turn into columns in other tables, in your database tables. Reason is because you want a lot of control from the you need a lot of control over the table as you design it. You could kind of do it with a spreadsheet program, but this gives you much more a better view of how the table is composed. The first column in this field will be the name of the field, the equivalent of the column heading. Second column of this field will be the field type, the data type. When you create a spreadsheet, of course you're selecting whether it's a text or an integer or a float or a currency or something, a formula, whatever. As you design the table here, you will have them all laid out, names of the fields and the field types all ready and laid out for you to inspect. And it gives you a lot more insight into how the table is constructed. The third column is a description column, where you just enter information, little comments about what is going to be in, what is intended to be in this column. So to reiterate, every column in the design table view is going to designate, or every row in a design view is going to designate a column when the actual table is created. So everything will flip 90 degrees on its side after we've designed the table. You design the table first before you enter any data, just like you design the column layout in a spreadsheet before you enter any data. And we can go back and edit this, just like we can edit the layout of a spreadsheet. Except once you've put data in it, you have to account for that data being affected by a change in the edit. So this is why design, just like with a spreadsheet, has to be thought out first. Now we're going to create the rest of our table. What we have here is an elementary farm spreadsheet. And this table, or elementary farm database, this table will be the crops. We'll have the crop name, the growing season it grows in, the soil type, whether it's drought tolerant or not, how much it costs to grow, and what the profit is. But the first row in the design field, which will be the first column in the spreadsheet, is the crop number. It's an integer field, integer data type. this is very important with relational databases. Doesn't come up with spreadsheets. Every line, every field in a table in a relational database should have something called a primary key, a number at the beginning which is unique, usually an integer that auto increments, that designates this line as, different from all the others, makes the line unique. Just a serial number for the line. This is very important because relational databases will often change the order of rows in a table without your seeing it, without your knowing, just because that's the way the mathematics of the system works. They change the rows unexpectedly, but as long as each row has a primary key, a serial number at the beginning, it will you'll be able to tell where each particular field is in the database. You'll be able to locate it because the indexing of the database will keep track of the primary key. And you see up in the red circle, there's a little icon that designates primary key. It's a little gold key icon. You have to affirmatively select that with your mouse. Technically, a very small database like this doesn't need a primary key, but every relational database must have it. And that way, because you're going to have rows which are complete. Often you will run into instances where you will have two rows that have identical data. With a large relational database, you'll encounter people with the same name or people who live at the same address. And if they're in different rows, the primary key number will help you tell them apart. This is a larger view of the table design screen. When you're creating the primary key or any other number field, you have the opportunity, any field, you have the opportunity to define whether entry must be required, i.e., can you leave the field blank? In a table, some things must not have a blank value. Primary key is the best example. The first information column in a table should probably be entry required as well. No nulls are permitted, in this table, which, the first, information column in the table is the name of the crop. You can't really have a field with no crop. You can't really have a crop with no name in it. That doesn't make sense. So you have the option to select at the bottom entry required, and some fields can be left blank. You might need to leave some fields blank. So for every column on the table, every row in the design sheet, you're going to consider whether you want entry required or not. There are other settings there. Length, default value, format value. You can fill those out, change them, or leave the defaults, whichever is most convenient for you. Okay, there's also auto value. With primary keys, every row that you add to the table as you actually enter the information, primary key will increment up. So you select auto value in the pull down list at the bottom as you're selecting primary key. That way row 1 will be row 1, row 2 will be row 2, 3, 4, 5, etc., integer after integer. However, if you delete a row in the future, the primary keys will not change in all the other rows. You'll have a void in the number progression. But that can be useful information. It can tell you when a row has been removed for some reason. So this is the design field. Once you've filled out the design, you fill out the table view. You actually put the information into the table. So along the top you have these column titles. These were the names we put into running down the second column in the design view. Remember, we typed in crop number, we selected primary integer, we told it was going to be primary key. And the second line of the design view, we typed in farm product and said it was going to be text. Third was growing season, etc. And there was a true false value for drought tolerant and cost and profit. So what was running down the table in design view is now running across in table view. And this field, this view allows you to actually enter information into the table of which crops were growing. And crop number auto increments. It starts at 0 and increments by 1 because it's an integer. And you don't enter anything into that. You just hit enter after filling in the rest of the line, and the auto field automatically fills that in. So once we fill out the third line and hit enter, crop number will be 2 in that where it says auto field now. And so you can also check off yes or no for the true false value for the drought tolerant. And another tick box will automatically populate once you get there after filling in the rest of the line ahead of it. So let's fill in some more values. Well, just quick, to jump back into the database landing sheet, if you want to edit a table, i.e. change the settings, going to design view, you select edit from the right click menu of the table you select. If you want to enter data into the table you've designed, then you select open. That will allow you to do data entry. And so I've added some more agricultural products here. You see crop number on the left hand column is auto incremented, and we have all the information of the different types of soil and whether it's drought tolerant and how much it costs, etc. You'll notice values repeat. There's only 4 growing seasons, at least in this universe. You know, I suppose a real farmer might make it much more precise and have 10 growing seasons. There's only 5 soil types, so the soil types repeat. You know, a real farmer might have many more, but there'll still be a finite number probably. But they'll repeat because there are fewer soil types in this instance and in most instances than number of crops to grow. So you're going to get repeating values in these columns all the time. And cost per acre, you know, will change for every crop, but it will occasionally repeat as well because, you know, prices often match up. So now that we've created this table, we're going to query it. You go back to the landing screen and select the query mode to the left of the on the main landing screen, and it brings up create query. What is a query? Query is just asking the table to display information that you want and not display information you don't want. Basically, unless your query returns the whole table, you're limiting what part of the table is going to be displayed. so that it's easier for you to pick out the relevant information and relationships. So what we're going to do is specify which fields we want to see, which columns we want to see, and the result will probably be, in this instance, will definitely be much smaller than the full table. So we created query and design view, and this is the query design table. It brings up an alert box as you open up. It gives you an option to select one or more tables that you're going to query. You can query several tables at once. In this instance, we're just going to query one table. We're selecting the farm product table and adding it to the query. And you see there's a whole list of all the columns in farm product table. Crop number, farm product, growing season. Again, that white box in the upper left is all the columns, again running down instead of across because we're in design mode. And down at the bottom is a grid. All the columns on the bottom, you will select what columns from the table you want displayed in your query. So what we're going to do is just going to select, I believe we select farm product and growing season in this instance. We select in the, you activate the field box opposite, next to in the first column, there will be a pull down list which appears. And that allows you to select which field is going to be the first column in your query. So we select selecting the first one, farm product, would actually select the whole table and display it. We're only going to select one of those columns. See, the name of the table is farm product, and for purposes of referring to individual columns in a whole assembly of tables, each column will be prefaced by the name of the table. So farm product crop number, farm product, farm product soil type. And then we're going to have a table that has fields. And one of the columns in the fields table will be soil type as well. So that column will be referred to as fields.soil type. But here we're only querying one table. We want to select only one column. So we selected, what we actually did in this instance, the original table, farm product came first, and then we had, farm product crop number came first, then farm product, then all the other characteristics. We're reversing it here. We're entitled to do this. We selected for the first column to be displayed in our query, we selected soil type, not farm product, and we selected farm product second. That way, you can see the query has been done and it appears up top. We have the soil types on the left and then the farm products on the right. We see that maize grows in dry soil, wheat grows in dry soil, sorghum grows in loam, oats grow in bottomland, on and on and on. And soil type column is arranged by soil type, not alphabetically. You could make it that if you wanted, but you'll see since we have two crops in the master table, we have two crops which grow in dry soil, and so you will have two rows in the returned query, one for each crop that grows well in dry soil. The others, the original table, each crop only grows in one type of soil, so you only get one return for all of those. But basically this query answers the question, what product grows in what soil type? And since we're limiting it by soil type, that's the first column in the returned query. which is a table of itself. The query is a table that you produce that answers a question derived from the data in the other tables. And you see down below, we made this query by selecting soil type as the first column and farm product in the second column. And after we did that, we also selected visible. There's a little visible click box so that you can, you could technically suppress the visibility of a column if you wanted to. With the query button. Query button is in the top row of tools, top row of buttons. There's hover text. It's not immediately apparent, but once you've selected what columns you need, you find the Run Query button. That's right there. You can tell from the hover text, and it will run the query immediately. This doesn't look incredibly impressive, but imagine you have hundreds and hundreds of columns and millions of rows, and you want a specific piece of information. You can cut that all down to the smallest return you want. So, of all the people in the United States, find the person who owns a 1948 Packard and what town they live in. It'll come right up if you properly specified the parameters of your query. So that's just a quick query. Later on we'll query multiple tables or make more complex queries as well. Today, just we installed OpenOffice and toured the base environment. Base environment allows you to create tables, run queries. Later we'll learn how it runs reports. And we created a table using design mode, and then we displayed the table layout. We filled in the data in the lookup mode, and then we queried the table. We selected the columns we wanted returned, and it rearranged the data so that we could see it backwards. Instead of crop type being the first column, we made soil type the first column, and we could tell because soil type was the first column, very easily we could tell which crop grows best in which soil. So next up we'll join two tables. We'll have to make two tables first, and I hope you continue watching. Again, here there will be a card for my original What is a Database database tutorial if you want to see that for more background. Thank you for watching.